Afternoon, my name is Amanda Gagne. I teach at Penn Manor, and here's my Module 3 theory. Didn't make my bot. It goes ahead and works. It vibrates nicely. So the question of the week was, how does this BristleBot work? What are some BristleBot's essential parts, modifications, and how can we go ahead and use other materials to make the design? And that's what I'm going to be talking through as I go through this presentation. So the Imagine stage, I really had to go through what is the purpose of this bot. I love that the directions had pictures, but using that previous research allowed me to really come up with what this idea was going to be looking like. I used the protocol that's provided for us. I followed the directions precisely. It does go ahead and vibrates, which is great. There it is. And I followed the images. Creating, I loved how simple it was. I did have to reposition the motor because the end of it didn't spin freely, which was one of the directions. I just had to replace it a little bit. Improving, things I did while I was researching, I saw some people, instead of using like sticky tape, use a rubber band, although I don't think that's going to change much about the actual design. I saw some people use these for like tournaments, so you can like have them inch forwards and push them off the field of battle and battle with them. I also saw like bowling, so maybe using a bigger brush. I thought I have horses, like using a soft horse brush for their face is a little bit bigger. Probably about like this big, or like a scrub brush for like a bathroom sink or something would be great. With that, then you have to adjust your battery and your motor size, which would be great things for students to research. Looking at the chart, so like I mentioned, as they're going through that protocol for remaking their prototypes, they can go ahead and really try to think about what the battery requirements are, motor requirements are. It's going to bring in a lot more of this math side to things, making sure that you have the correct battery power for what you're trying to use. We could talk about RPMs of this motor here. All this together brings in the science and engineering components of students analyzing. Maybe they're measuring how far this moves and changing their design to get it to move farther. Maybe they are battling, seeing how fast these can move. All those great principles connect then to science of seeing how does a battery circuit go ahead and move this motor. That motor itself could be a whole lesson. I would use that for something like my engines class and just seeing how that moves and counting RPMs. Models were used. Students made new ones based off the prototype that they made. Looking at the chart 5.1, I don't know if it's that connected to a real world problem, unless you're making this like as a sweeper maybe. So they might be able to relate to it. Students can allow for some creativity with this. Like I could see us connecting Christmas lights also to this battery. That's a lab I do with my electrical wiring unit, and they can add like different lights to it. But overall, like they can use different types of brushes, but it doesn't allow for too much creative freedom. You're kind of restricted to these parts. Otherwise, I think it's a really great lesson that allows for the engineering design process. It's student-centered, it's hands-on. Students are working together to build this and brainstorm and research, so all those make up good quality STEM lessons. Thanks for listening.